Hello again. We're doing scientific notation, and this is something that belongs in exponents as well, because you can do problems with exponential properties here. It depends actually. I'm not really the biggest fan of scientific notation. Basically what you do is you turn really big numbers into problems in scientific notation, or you take really small numbers and you turn them into problems in scientific notation. That's pretty much it. I mean, when I do these problems, I usually have students who just do it in a calculator, and there's really no way I can really stop them if it's a calculator test. Well, I mean, I suppose I could, but that's kind of trivial in its own right because they're already telling me they're learning the properties, so scientific notation is kind of like a subset of it. Although it's always covered in a book, and you'll always see it, so since that's the case, we're going to go ahead and go over it. I mean, it's useful. I mean, you see it in chemistry, I guess you can see it in physics, rocket science, etc. Let's keep going. So I've got this number right here, 42,553,000, pardon me. And I want to turn this into a problem in scientific notation. This is how much I always say I take home, this is how much I make as a teacher, which isn't true, but nobody really cares at that joke. Anyways, I want to turn this into a problem with scientific notation. Well, what I got to do is I got to basically have a number, decimal, number times 10 to the power of something. Do you see a decimal here? And the answer is no. So if you don't see a decimal, it automatically belongs at the end of a number. And basically what I'm going to do is I'm going to move the decimal to the first number that's not a zero, in order from left to right. So the first number that's not a zero from left to right is 4. So I've got to move it 1, 2, 3, 4, 5, 6, 7. So I moved it 7 times. And here's how I'm going to write it. 4.25, 43, and I'm multiplying by places of 10. Every time I move a decimal value, it's always times 10. And you just memorize that too. So it's 4.2543. And I don't need to write 0, 0, 0 because you automatically assume that they're just zeros afterwards. That's pretty much it. You don't need to write, if the rest of the numbers are 0, you just don't write it down. Times 10 to the power of, and since I moved 7 places, it's 7. Now what I tell my students is, if the number is bigger than 1, I was a rich man, so the exponent is going to be positive. Now if the number is smaller than 1, i.e. 0.00 something, then I'm going to be a poor man, and that's going to be a negative exponent. So I put these two examples next to each other, and I say, well, this is how much I make as a teacher. And then after taxes and all my payments that I have to make, this is how much I actually take home, a fraction of a cent. Still nobody cares for the comment. So I move this decimal right here, because I do see a decimal, to the first number from left to right that's not a 0, after the first number. And the first number I see that's not a 0 from left to right is the 5. So I'm going to move it after the 5. Boom! I moved it 4 times. So I'm going to have 5.32, because that's where my new decimal is, times, and since I'm moving a decimal place, it's always in powers of 10. It's based off the metric system. And since I was a poor man and I moved it 1, 2, 3, 4, you better display that you were poor. If you write 4 times, it means that you were pretty rich. If you write -4, it means that you were less than 1. So if it's a number greater than 1, the exponent's always going to be positive. And if the number is less than 1, the exponent's always going to be negative. So I look at these problems here, and what I have is, I have students who say, forget you, Mr. Shahadi. I'm putting parentheses around the numerator, I'm putting parentheses around the denominator, whatever I get is the answer, and that's it. Well, I suppose you could do that, but let me go ahead and show you how you can do it without a calculator. So if you got a problem like this, where it's multiplication, all you do is you take the bases, 2.5 times 2.5, that comes out to 6.25, times 10, and you're adding these, 10 to the 8th and 10 to the 2nd is 10 to the 10th. And that's the answer in scientific notation. If you wanted to put it in decimal notation, you just move the decimal over 10 times to the right, because you're a rich man. It's going to be a bigger number. If it was negative, you'd be poor, and it's going to be small. This one, if you want to do this without the aid of a calculator. 4 divided by 2, 2. 10 to the third divided by 10 to the fifth, you subtract them. 10 to the negative second. Bam! Done. Scientific notation. If you wanted the answer to be decimal, then, well, the decimal would be right there, and you move over 2 times, so it would be 0.02. But usually, when we do these on a test, I say, leave it in scientific notation. Sometimes, if I want to, just test the students, I say, put it in decimal notation. For this one, it's 2 to the power of, well, it's 2 to the power of 1 over 4, so it's 2 to the fourth. And let's go right there. Times 10 to the power of 12. This is where I can make students learn, where I can make sure they learn from their mistakes. 2 to the power of 4 is 2 times 2 times 2 times 2. That's 16. Times 10 to the 12th. That is not the answer. That is not scientific notation. See, the decimal is right here. I want it after the first number that's not a 0 from left to right, so it should actually be right there. So it's 1.6 times 10 to the power of, and since this number was bigger than 1, 16 is bigger than 1, the exponent's going to get bigger every time we move it. So instead of 12, it's going to be 13. And you can check them out on your calculator. You can do 16 times 10 to the 12th and 1.6 times 10 to the 13th, and I promise you they'll come out the same. I don't know what that is off the top of my head. That's 12 zeros. 100,000, million, billion. I think that's 16 trillion. I don't know off the top of my head, but I'm pretty sure that is it. Okay, that's scientific notation. Part of exponential functions, kind of. Yeah, that's it. Have a good day. Goodbye.